Dear participants, in this session we will see that how to control a DC motor using Uno platform. Here uh, this is the Uno platform with screw shield that we are using for all our experiments. This is one genetically prepared board. You can see this is the motor. This is BO motor or TT motor as it's typically called. This is the DC motor you can find, and there is some gear arrangement to reduce the speed and enhance the torque capacity of the motor. So we can simply connect this wheel just for easiness of demonstration. And you can find here, this is the interesting thing. Here we are using actually the driver module that is used for driving two such type of motors. So if there are two such motors that can be driven by single driver unit, this is L293D L293N driver unit. Okay, you can see here heart of this module is this thing. This is the IC. You can find here it is L298N. It is high current capacity IC that then you can use high torque motors that draw significant current, and that's why this heat sink is connected to it. This is the heat sink, you can see, so that the heat that is generated or that is dissipated through this IC that can be easily negotiated. Now you see here the terminals are of importance to us. You can find this is terminal that we have to connect to plus 12 volt. Then there is ground, and if an external 5 volt is required, then we have to use this terminal. You can find in this board there is a 7805 regulator. So if we apply 12 volt here, this regulator ensures that a regulated 5 volt is available in the board for its operational purpose with the IC and other sort of things. Now this is a jumper. You can remove this jumper also. You can simply remove this jumper like this. You can see, you can remove it. Now you can see when this jumper is removed, then this internal 7805 will be non-operational. And if you are connecting the board to this Arduino, then this Uno 5 volt pin should be connected to this third terminal. We will be using this jumper, and therefore we will be using the onboard 5 volt facility. Now these are the two terminals to which you can connect your motors. The two terminals of the motor has to be connected to the two terminals, and since they are DC motor, there is no question of polarity, because changing the polarity will change the direction of rotation of the motor. Now comes these pins. These are of very importance, high importance. You can find here there are one, I do not know what. Okay, this is pin number 1, pin number 2, pin number 3, pin number 4, 5 and 6. There are in all 6 pins. You can see these are the 2 pins. What is written over there? Okay, I will be going for a figure of the same. Okay, that will be better. Okay, I will get a magnified view of this thing. You can see here that these 3 pins. So if you just think of a center barrier, then there are 3 pins on this side, 3 pins on this side, that is on right 3 pins, left 3 pins. So these 3 pins on the right, they are responsible for controlling the motor that is connected to this terminal, and the 3 pins that are on the left, that takes care of the motor that is connected to this left terminal. Okay. Now you see here that these are named as IN1, IN2, IN3 and IN4. This pin is written as ENA and this is written as ENB. Again you will find that this ENA and ENB, they are having jumpers. I will show you here. You can see this is the enable pin and it is having the jumper, and here the enable pin does not have the jumper because we are using the enable pin. Okay. So here I have not used both the motor terminals. I have used only one of the motor terminals. So therefore I will be concentrating on 3 pins only. 3 pins, and 3 pins are free for this configuration. Now you see that what does this mean? Remember that using this IN1 and IN2, and if this jumper is there, you are unable to control the speed of rotation of the motor when you are using the jumper. Now using this IN1 and IN2 pin, you can simply control the direction of the motor, making IN1 high and IN2 low will rotate this motor in one direction, this motor 1 in one direction, that means either clockwise or counterclockwise. I just cannot recall, but you can just go through it, its literature. And if you reverse, that is you make this IN2 high and IN1 low, then this motor will rotate in opposite direction. Same is this case. If you make this IN3 high and IN4 low, your motor 2 will rotate in one direction, and the opposite will happen if you change this low and high status. And remember that if you put this jumper on or it is in its place, then absolutely you are unable to control the speed of the motor. However, you remove this and you connect this pin to one of the PWM outputs of the Arduino. Then by changing the pulse width to this pin, the speed of the motor can be controlled. Okay, so let us get back to this view. You can see here these are the 3 pins that we have to connect to the Arduino. What I will do, I will go to the program and see that how we have made the connection, so you can see direction pin 1 we have connected to digital pin 1, direction pin 2 we have connected to digital pin 2. Now this is the name that I have given, DIR pin 1, DIR pin 2. So I will connect IN3 to pin 1. So you can see this wire is connected to IN pin 3. I will connect it to in 1. Okay. Then input pin 4, it is connected to digital pin 2. You can see the pins are connected to digital pin 1 and digital pin 2. And again we will go back to the program You can see this speed pin. Okay, this is not the program. I will go for another program actually. Just I was going for a wrong program. Yeah. This is the program. Okay. Now you can see that okay, this cannot be yes. This we have to remember that we have to use such a digital pin which is capable of generating a PWM signal. Now pin number 3, digital pin number 3 is able to output a PWM signal. That's why we have connected the speed pin, that is the enable B pin, to pin number 3. I got a bit confused. Okay. So we have connected it to pin number 3, as you may find. Pin 1, digital pin 1, digital pin 2, digital pin 3. This orange wire is IN3, the violet wire is IN4, and this green wire is ENB3, ENB pin. That is, these 3 pins are right now connected. These 3 pins are connected. Okay. Alright, now the motor that has been used, it works on 12 volt. So we have used this external supply pin, and definitely the ground has to be connected. So I will connect the ground to Arduino Uno ground pin. Connection I have made here, and that's all about the circuit. Now I will see first the operation, then I will explain the code. So I have to connect the Arduino first. So I will do. Okay. So is visible right now. So I've connected the Arduino, and I am to connect the power supply, but before that let us upload the sketch. This is the thing. We've compiled it, and we have loaded it. Okay. So now we will put the supply on, and let us see what happens. So now I have given the supply. You can see I will reset the Arduino, because yeah, now you can find. So you can see it rotates at a lower speed, it rests for a while, it rotates at a higher speed, then it rotates in opposite direction at a lower speed, then it rotates in again opposite direction at a higher speed. I think the operation is clear. Let us discuss the code that is interesting. You can see here initially we have declared the pins, pin number 1, pin number 2, and pin number 3. Now pin number 3 is the speed pin. So this pin we have to choose in such a manner that we can have the PWM signal. Okay. Otherwise, just using a digital pin that does not have the PWM capacity, it is not going to serve the purpose. Now you see, then it is necessity that we declare whether the pins are input or of output operation, output type. So pin mode function has been used. Direction pin 1, direction pin 2, and speed pin, they are all of output type. Initially we will write low to the direction pin 1, low to direction pin 2, and now you can see these two are digital writes, and here I will be writing analog write, because we are going to use the PWM capacity of that pin. So we have gone for analog write. This speed pin is 0. Then we have to stop a while. So that's why we have given a 2-second delay here. Now let us go for the loop. That was the setup part, and let us go for the loop. You see, initially we have written digital write direction pin 1 high, digital write direction pin 2 low, and we have given a certain speed 110. This is actually the PWM value. We can go up to 255 as we know. So this is 110 we have given. So it will rotate at a certain speed. The delay is 3000 it is given. Next you can see both the direction pins are low. That means it will stop. Then again I have made high and low. That means the same fashion on the same direction it will rotate, but now at a higher speed. You can see here it is 250. We have given the delay. This is a significant delay that is given. Okay, I will make this also with 3000 so that we can see properly. I'll compile it. Okay. So now it will rotate at a higher speed for 3 seconds. Now both of the pins are low again. So the motor will stop. The delay for 500 millisecond, that is half a second, is given. Then you can see that we have simply reversed the signal status in the direction pins. Now earlier it was direction pin 1 was high and the direction pin 2 was low. So here now we have made direction pin 1 low and direction pin 2 high. The speed pin is again having the lower value 110. That signifies that the motor will rotate at a lower speed. There is a delay, so that for that much duration of time, that is 3 seconds, the motor will rotate. Next it will stop for half a second. Then again you can find that the same fashion of signals has been maintained in pin 1 and pin 2. Pin 1 is low and pin 1 is low in both the cases, and you can see the direction pin 2 is high, the direction pin 2 is high, and the speed is now 250. So earlier it will rotate at a small lower speed, and after that it will rotate at a higher speed. So you can see this is okay, I will give it 0. This is all about the program, and then it will stop for a while, maybe for half a second. So I will make everything this 3 seconds, okay, so that there is no confusion for us when we look into the program. So initially it will rotate at lower speed. I will make the speed further lower, maybe 90, so that we can make it actually. And I will make here 90. All right. If you actually you are giving the PWM signal in order to control the voltage at that pin, isn't it? So if you make it very low, then the voltage will not be sufficient. It creates a just a chirping sound and the motor does not rotate. It happens. So therefore I have kept it 90. So I will here what will happen, it will rotate at a lower speed for 3 seconds, it will stop for 3 seconds, it will rotate at a higher speed for 3 seconds. This all will happen in one direction. It will stop then for 3 seconds, then in opposite direction the same phenomena will be cycled, repeated. Okay, so let us now see. I will give the supply, I will reset the Arduino, and you can see here. Now you can see you have found that sound, but it is not rotating. Now it is rotating. It will stop. Okay, it is able to rotate at lower speed on the opposite direction. This may be due to some misalignment in the internal gear mechanism. There is absolutely no problem with the program. Now it is rotating at the higher speed. It will stop. It is rotating like that. Okay, so this is all about controlling a DC motor. You can now see that you can take a robotic structure. On the front wheel you can use a dummy wheel, a dummy that such type of fulcrum type of wheels are there, pivot type of wheels are there, that you can put in the front section of the robot or the nose of the robot. And the rear wheels you can use two such motors. You can control the forward motion, the reverse motion. If you rotate one of the wheels at a slower speed and the other wheel at a higher speed, you can make the robot take a bend in rightward direction or leftward direction. You can use four motors to have drive in all the four wheels of the robot chassis. So you can do all sort of things, or you can take help of some sensors. Suppose you are using an ultrasonic sensor. When the sensor is not finding any obstacle in which way the motor should rotate, that you can decide through the sketch, or there if there is some obstacle you can control the motors in such a fashion that all the motors are stopped. So all these things you can do. So it all depends on your interest and the particular project that you take in your hand. I have just told you the generic things so that you can develop your own system. For any of the confusions, kindly let us know through your comments in the comment box so that we can get back to you with the solutions readily. Thank you, and let us keep on experimenting.